Welcome to David Alexander Maths Tuition. This is chapter 3a on linear simultaneous equations. So let's have a look at the first example. We've got 4x plus y is 16 and 7x plus y is 25. So the question we need to ask ourselves is, have we got the same number of x's? No. Have we got the same number of y's? Yes, we do. So we are going to eliminate y. We're going to write an equation with y not in it. So looking at the y's, have they got the same signs or different signs? They have the same sign. So we need to remember this. Same sign, subtract. Okay, if they're not the same sign, we would add. So 4x minus 7x is negative 3x. 16 take away 25 is negative 9. To be honest, we could have done the subtraction going upwards, or we could have just flipped the equations the other way around. There's no reason why the 4x plus y equals 16 is on the top. We could have written it on the bottom. So if minus 3x is negative 9, then 3x is positive 9, in which case x is 3. And if x is 3, we need to do a substitution to work out what y is. So I'm going to use the top equation because it's easier. So if x is 3, then 4x is 4 times 3, which is 12, and 12 plus what is 16? 12 plus 4 is 16, so when x is 3, y is 4. Let's test it in the other one. 7 times x, 7 times 3 is 21, plus 4 gives me 25, so I know I've got it right. So on the next set of simultaneous equations, we've got the same number of y's, but they have different signs, so it's not same sign subtract. We are therefore going to add these equations. So we're going to get 5x, negative 7y, plus 7y is 0y. Not even worth looking at that. The whole point of adding them is we are eliminating these 7y's. And negative 2 plus 22 is 20. So 5x is 20, so x is 4. And if x is 4, what is y? I'm going to use the bottom equation just because no real reason, just it doesn't have a negative number, I guess, is what's put me off the top one. So 2x is 8, so 8 plus 7y is 22. So 7y is 22, take away 8, which is 14, so therefore y is 2. Let's test it in the other one. 3 times x is 12. 12 take away 14 is negative 2. Perfect. So I know that these solutions are correct. Okay, so here we've got a bit of a problem because we don't have the same number of x's or the same number of y's. But I can easily double this top equation to turn that into 4x plus 6y equals 38. And the other equation is 4x plus 5y equals 35. So I've got the same number of x's, they are both positive, so I'm going to do a subtraction. So that's going to be no x's, of course. 6y take 5y is 1y, 38 take 35 is 3. So y is 3, and if y is 3, what is the value of x? Well, if y is 3, then 3y is 9. So 2x plus 9 is 19, so therefore 2x is 19, take 9, 10, so x must be 5. And again, if you want, test it in the other equation, and if you're getting 35, you know you've got it correct. Now this bottom one's a bit more problematic because I can't fiddle the top one to balance the x's or the y's. I can't fiddle the bottom one to balance the x's or the y's. So I need to fiddle both. So what I could do is multiply the top one by 5. And if I'm multiplying the top one by 5, I need to multiply the bottom one by 3. That will balance the x's. Or I could multiply the top one by 2. And if I do that, I'd need to multiply the bottom one by 7. It's up to you. I personally think I prefer multiplying the top by 5 and the bottom by 3, just because, well, 7 times table's just a bit nasty, really. So multiplying through by 5, I'm going to get 15x plus 35y equals 5 times 13, which is 65. Tripling the bottom one is 15x plus 6y equals 36. So I've got the same number of x's, they're both positive, same sign subtract. 35y take 6y is 29y, and 65 minus 36 is 29. So 29y is 29, so y equals 1. Now I'm going to do my substitution to solve for x, and I can use any one of these 4 equations. I might as well use one of the 2 original ones since the numbers are much lower. So I'll use this top one. 7y, if y is 1, then 7y is 7. So 3x plus 7 is 13. So 13 minus 7 is 3x. So therefore 3x is 13, take away 7, which is, why am I struggling with that? Don't tell me I need to use a calculator, of course I don't. It's 6, 3x is 6, so therefore x is 2. And again, we can test that in any one of the other 3 equations, and if we get 12 or 65 or 36, then we know we've definitely got that answer correct. Solve by substitution. Okay, so what we did before was solving by elimination. So what I'm going to do here is solve by substitution. So if 7y minus x equals 9, I'm going to subtract 9 and add x to both sides. So x is 7y take away 9. So if x is 7y minus 9, then I'm going to replace this x with 7y minus 9. So I'm substituting into the other equation. I'm replacing x with 7y minus 9. So that's going to be 3 lots of 7y minus 9 plus 2y equals 19. Expand the brackets, so that's 21y, take away 27 plus 2y equals 19. So that's 23y is 19 plus 27. And 19 plus 27 is 46. So 23y is 46. So y, 46 divided by 23, y is 2. And if y is 2, then x is 7 lots of y minus 9. So 7 times 2 is 14. 14 take away 9, x is 6.